about now?
Yes, this is perfect now.
Okay, so I'll go with this module. Hello again, my name is Pericles, and I am a research scientist with the Hellenic Naval Academy. I'll talk about research that we started, and it's titled Design of a Controlled Defense Vocabulary, Encoding Terms from NATO Press Releases. This is the outline of my presentation. I'll first try to give you a background so as to help you, understand where this research that we have just started belongs to. And then I move on with our motivation for this research and its relevant objective. I will talk briefly about relevant research as it is found in the literature with respect to controlled vocabularies, and then I will discuss my methodology, and I move on with results and discussion, and finally I close in with the next step. So imagine that you would like to write a book that you know very well a subject, or you have lots of information about a subject, about a thing, and you would like to put it in a comprehensive way and form it in a book and then share it with with people. So in order to write a book, in order to put this your knowledge and the information that you have in a certain format, you need to have words. Okay, words are a combination of characters representing a spoken word. For example, if you want to write a book about a recipe, how to cook a dish made of fruits or vegetables, for instance, you need words like recipe. Now, besides words, what else is needed? It's terms. We need terminology. So terms are words, single words or phrases, like a combination of words that are used to describe a thing or to express a concept in a specific domain. For instance, again, if you write a book about recipes about fruits, you can use the term avocado, or you can use the term glazed avocado, right? So all these words and the terms that you use, they form a vocabulary that is used to write this book. So it's a specific vocabulary, mostly about fruits, and vocabulary is words employed by a language, okay, in a field of knowledge. So in our case, apple, oranges, avocado, sliced pineapple, and stuff like that will be part of this book and part of course, of the vocabulary. Then this book is something that yields knowledge. So the book becomes a knowledge base, right? And that's in a comprehensive way. It's put together in a comprehensive way. It has structure, which is basically the syntax and the grammar where the words can play in, and it's stored in the book. It's stored in the knowledge base, and it has sentences. It has chapters, and that's how we have the book. Now, this vocabulary that is specifically for writing that book is called the control vocabulary, which is a comprehensive collection of domain-specific terms to describe knowledge in a specific domain. In more specifically, in the control vocabulary is also technology. Is a technology of the semantic web, and it helps to do certain to accomplish certain tasks. For example, it helps control vocabulary technology helps us to mitigate data and mitigate data ambiguity. Specifically, for instance, let's say that we have a database of proper names, and we want to retrieve names of specific people. Often people share middle initials, or they share first and last names and stuff like that. For example, we have the name John Robert Smith and John Ronald Smith. So if in a database the name is indexed as Smith first, like the last name is first, and then the first name is second, then the R, the middle initial is also recorded, and we try to retrieve the name, we have these, out of lack of other definition, we can retrieve multiple names with this of the, like Smith, John R, that may not be the information that we need. So a control vocabulary help us to mitigate this type of data ambiguity. Then the other thing that helps us to do is to define the characteristics of knowledge resources. So for instance, we have, let's say, a book out on the web somewhere, and it has a specific address So it's accessible, and all this information in the book is accessible via an address, which is called a universal resource identifier, for instance. This other thing that helps us a vocabulary to do and to accomplish is to support semantic interoperability. For instance, it helps to automate data exchange between computer systems that recognize, for instance, medical symbols, or they can understand cryptography information and terminology and stuff like that. And also, control vocabulary helps us to facilitate integration of ontologies. Ontologies in the field of computations, for instance, is the collection of concepts that are used within a domain and the relations within these concepts. So a control vocabulary can help to integrate existing ontologies and build a single ontology out of these by shared concepts or shared definitions about concepts. Types of control vocabularies are thesaurus or thesauri. So these are concepts organized in a hierarchical and associative fashion, and they provide semantic definitions. In sciences, type of thesaurus is about astronomy, and I don't know if it's very clear in this from this screenshot on this slide, but here we have a thesaurus about astronomy, and there are different terms, and maybe if I can move these further up, you can see that if I select the celestial sphere term, I see related or synonyms to this term. Another example of the use of control vocabularies is in taxonomies. Taxonomies are basically hierarchies of inheritance, as it is mentioned in the literature. And another example of control vocabulary is on subject headings. Subject headings are a list of terms describing subjects in information systems. Here I provide the example of the Library of Congress in the United States, which is a collection of subject headings that helps researchers find information and or retrieve data and information from large databases. Another example is also the medical subject headings, if you have ever heard, like the mesh structure. Another example of the use of control vocabularies is in the development of terminologies. These are technical terms for proper communication between specialists of a specific domain. And in the health sciences and in medicine, for instance, we have the ICD-9 classification of diseases, the International Classification of Diseases, which is a World Health Organization structure for identifying diseases. And this is the type of the structure. And we also have terminologies, control vocabularies that are used in defense organizations, for example, like NATO. So NATO defines terminology, a collection of terms and abbreviations and definitions within the domain. And this organization has its own definitions and terms for facilitating communication between its members. So this research is motivated by our understanding to deal with the heterogeneity of content that is a special characteristic of war and conflict related newsroom articles and press reports. So what I'm saying here is that we would like to focus on information that comes from newsrooms that discuss that they provide reports, for war events or about conflicts. Now, newsroom articles are great sources of information because they provide information about social events, military events, diplomacy, biomedical facts, geography, and historical data. So they become like they are containers of very important information. And specifically for this project, we focus on newsroom releases, press releases about the developments of the Russo-Ukrainian conflict and how they are presented by the NATO press office. However, since press releases are text, and that means that they are written in natural language. Natural language has it's unstructured, basically. So before a computer program, computations can identify and extract and manipulate defense knowledge and war-related information, which is in a text format. The knowledge or information must be presented in a structured format. For that reason, our objective is to create a control vocabulary of terms related to the Russo-Ukrainian conflict, and therefore formally encode terms that describe events of this conflict. Relevant information with respect to the development of controlled vocabularies can be found in the literature. Here I have different examples. Rocha et al. Described the VOSER project, which is about the use of controlled medical vocabulary to help exchange patient data between different computer medical systems, like between different computer medical systems that are used in, let's say, hospital settings. Another project about Giordano et al. Is about the classification of educational resources as they are being used by the M-Educator Best Practice Network. Have et al. Also create and use control vocabulary to provide universal names and codes for clinical observations and facilitate the share of clinical information between medical professionals within within a healthcare system or intra-healthcare systems. And also in another example, Top et al. Create control vocabularies to help the WUR databases for domain-aware search. So we see that the control vocabularies as a technology of the semantic web can have different applications in different domains. Moving on with our methodology, it's in a very initial phase as an approach. And for that, I will discuss the data source identification and data collection. I will discuss our data wrangling and the data encoding for we extract information from news releases, right? And we encode it with a simple knowledge organization system, which is a technology of the semantic web as well, for encoding information as a control vocabulary. So the data source is NATO's newsroom and NATO's press office, and specifically NATO press releases. This is an example. This is a screenshot of the online functionality, the web tool that we use to query information about Ukraine and NATO and relation between these two institutions, right? And to retrieve information. Our simple query helped us retrieve specific information about Ukraine that goes as far back as 2001, I guess, and is up to date. And for the data that we retrieve, and again, for this initial phase, we manually went and we copied the body of the text, which is the very first paragraph that appears before, which is available and in public view, right? Before we click on the link to read the whole article, the whole press release about an event. And we collected this information and we organized it in a spreadsheet. It's like 3 columns of information. One is about a date that identifies a date of the article released about this event. Then we have the title of the event, and then we have this first paragraph which defines the text of the press release, and then what we did is we tried to clean this data for like artifacts that we probably collected while we try to identify and store the data in a spreadsheet. And what else we did is that we split programmatically the paragraphs into sentences, And then we developed a label scheme to 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 tag over to label the terms that we were interested in analyzing and encoding in our analysis. So it's if you're familiar with text analytics and natural language processing, this is a very similar process to named entity recognition, but uh, but on this stage of the project and this phase, it's not named entity recognition yet. It's going to be right in the next phase of the project, but I can give you a brief example. So we have for instance, we have text from a press release, and we find the word Kyiv or the term Kyiv that we encode as city. Then we find another word that we call as another term anniversary that we encode as event, or we find the NATO Information and Documentation Center that we encode as organization, and such forth. For instance, we find in another press release, we find the word frigate, and we encode it as edges or arms, or civil instrument for defense, and other information that you can see the example right here. After we do this encoding, we have developed a classification scheme, and we see that the umbrella label for classification is called NATO, and this because NATO provides us the information to collect the information for encoding that we're interested in, and then we for each of the term we provide 3 levels of labeling: level 1, level 2, level 3, and then what follows is the information of the press releases. Again, in another example, we have level 1, level 2, level 3 of labels, and then the information that follows that comes from the press releases. And that's how we move to encode our information and present it as a comprehensive control vocabulary. For our encoding, again, we use the semantic web technologies. Semantic web technologies are part of the World Wide Web Consortium, or the W3C consortium. The W3C consortium. This is an international organization that creates technical standards and guidelines for web technologies. Specifically, we use the Simple Knowledge Organization Systems, which is a data model for sharing and linking knowledge and organization systems within the web. And specifically, in this initial phase of the project, we use concepts labels from SKOS. We use the preferred label of this SKOS technology, relationships such as broader and narrower, as I showed you on the previous slide, that we have 3 levels of encoding labeling schema for our data. And we also use the nodes label for providing the source of our information and of our definitions for the terms that we use. There are also other labels, as you see here, the mapping properties for probably helping to map data across mapping schemes and collections data and collection labels and others. Now, the advantage of the SKOS technology is that this is associated with the technology of RDF, the resource description framework schema. For the semantic web, RDF is the subject predicate object triple. These RDF triples are the building blocks of ontologies, and they hold the logic behind an ontology, and the triples can be extended and be represented as a graph. And the graph is a data model that has mathematical underpinnings. So we can do statistical analysis on that data. We can do mathematics with this data, and we can do description, logic, inference, and stuff like that. So terminology in SKOS format is defined as RDF data. So therefore, SKOS data model is defined as an ontology according to the W3C organization. And that helps us a lot in formalizing the data that we collect and we want to model. And this is an example of representing once we have encoded our data with SKOS, we can represent it in a tree-like representation, right? And you see that we have the top concept, which is NATO, for which we have encoded some definition that we have retrieved from the website of the organization. The next level of this encoding is for the Security Alliance Network, which is according to the organization. It has a definition, which is practical means which basically tie NATO members together. That's the alliance. And then we have another term, which is assembly. And we provide a definition that we also looked up and found in a dictionary. And what is an organization? So we talk about an organization, and then we encode. We encode as SKOS information that comes from these press releases. This is another example of how we encode information about legal instruments, right? And what can be a legal instrument within the NATO organization system. And we move forward.
Professor Llaneres, we have 1 minute more because we have to interrupt.
Certainly. I'm almost done. I have two more slides and I'm done. Yes. And we also use the SKOS Play functionality, which is an online tool to render and visualize control vocabularies in SKOS format. And you can see that once we use this encoded information with the SKOS Play tool, we can have a tree-like representation of our data, and it looks like that. And this is another example of our data and a different terminology and how it is encoded. And basically, we have over 1,400 concepts collected with over 1,400 definitions given to these concepts. We have 1,400 broader terms and 1,419 narrower terms based on our encoding scheme, and one top concept that I described earlier is NATO. And the classification of SKOS, it has 55 labels, 10 level 1 labels, almost 20 level 2 labels, and 35 level 3 labels. This is about addressing the multi-level hierarchical classification question, and this is to classify items that can belong to a multi-level hierarchy structure of classes. And the next step is to encode additional data and create a Russia-Ukraine conflict defense ontology that will help researchers, look up military, historical, biomedical information and stuff like that. So this concludes my presentation on this initial phase of our research. Thank you.
Thank you for the presentation. Any questions from the audience? Okay, since we are running a little